Alright guys and gals, so this is going to take us into our derivative unit. Unfortunately, I don't have the blank worksheets with me. I thought I did. I never grabbed them when I left school. So all I have electronically are the same worksheets, but it's the answer keys, and that's all I have. So I was going to print them out and white them out and then rescan them, and I said, you know what, you guys can look at the answer key anyway. So what I would have you do is just kind of do the worksheets on separate pieces of paper after you look at the video lesson here, and just sort of block out the answers, right? Try to do the work on your own and then check as you go. So I just didn't feel the need to, white out every little thing, and I just don't think it's necessary for you guys to learn. So just as you're going through, don't just copy answers down, okay? Try to do this stuff. This is calculus. This is what we're doing, right? It's all about derivatives here. And we know from the first 3 sections in Chapter 12 that the derivative, by definition, is the limit as h goes to 0 of our difference quotient, right? This is the definition. That's using the limit process. The power rule itself is a shortcut to this. But the power rule is specifically designed for exponents. And so we have to adapt it when we have different types of functions. So that's what I'm going to kind of do. We're going to do the power rule, the product rule, and the quotient rule this week. But they're all variations of the power rule. So the power rule itself, just to refresh, to find the derivative function, what you need to do is to go ahead and take the exponent, multiply it to the coefficient in front. So 3 times 4 is 12, and then you're going to drop the power by 1. And then you can do each individual term in the function. So then 2 times negative 3 is negative 6, and we drop the power 1. That has an exponent of 1, so we have 1 times 2, and we drop the power 1. And then this, any constant, is just going to go away, right? Because 0 times anything is just 0. So you end up with the quadratic. And again, because we're dropping the power 1, a cubic becomes a quadratic when we're doing derivatives. Now, if we have, if we want to look for tangent line equations, or we want to find the slope of the tangent line at any given point, we plug in here. If we want to find the location of the tangent point, we plug it into the function itself. All right, so keep that in mind as we're going through here. There's some application questions where you have to find the equation of the tangent line, use the tangent function or the derivative function to find the slope of the tangent line, and to find the point of tangency, use the original function, because this is a positional function where this is a function of slopes, right? So that's a function of slopes at every single point x along the curve. This is a derivative of this that's tied to that, right? Okay. Now, let's say, for example, we have something like this, where we have three over x squared plus 2 over x cubed. Can we apply the power rule to this, even though that is not a polynomial function? And the answer is, if we can write it with like a polynomial, but with exponents that aren't necessarily integer values or positive integer values like they are in polynomials, then yes, we can do that. So what what we would need to do first is rewrite this with its negative exponents. And then to find the derivative function, we would go ahead and apply the power rule just like we did. So pay attention here, though, because negative 2 times 3 becomes negative 6. And we're still dropping the power 1, so that goes to negative 3. And then minus 6x to the negative 4. Or if you wish to write it out without the negative exponents, this becomes the derivative of f. Same thing if we have some rational functions. For example, let's say we have the cube root of x squared minus the fourth root of x cubed plus the square root of 3x. All right. So again, not a polynomial function, but we can use it if we can use power rule if we can individually write these with, exponents. So this becomes x to the 2/3 power. Remember, it's power over root minus x to the 3/4 plus 3x to the 1/2. Okay, so now the derivative, this gets multiplied to the coefficient in front, so that's 2/3, and then we drop the power by 1 still, so 2/3 minus 1, or 2/3 minus 3/3 is a negative 1/3. And then minus 3/4 x to the negative 1/4. Again, that's minus 4/4. Now this is something entirely different, okay? Because inside we have a product which gives me something different. So we can't really do this. So I'm going to change this for right now. This is going to involve the chain rule, which we're going to do next week. I'm going to put the 3 out front so that this looks like this. And then I can multiply the 1/2 to the 3 and then drop the power 1. Okay, so any time we can go ahead and take an individual term and write it in exponential form, we can apply the power rule. All right, gang. Now these are the notes that I posted for you guys to take a look at. It kind of gives you an idea. So what you can do when you have a product of two functions, for example, like this particular example right here, and I'm going to go ahead and just continue. So this is, we're talking about the product rule, and we have two functions now that we are multiplying together. For example, if f of x is equal to g of x times h of x. So the product rule tells me, and when you see me do something like this, that means we're doing g prime. That is the derivative of g. Okay? So to find the derivative of the product of the two functions, we take the derivative of the first function times the second plus the first function times the derivative of the second. And this extends. For example, if we have three functions that we're multiplying together, where we have g of x times h of x times k of x, for example. You need to take the derivative of each one of these, like we did here, right? We took the derivative of both of them times the other function. In this case, it'll be times the 2. So the derivative of f becomes the derivative of g times h of x times k of x plus the derivative of h times g of x times k of x plus the derivative of k times g of x times h of x. Right? So g prime, h prime, k prime, and multiplied with the other two. And if you had 4, I mean, you could just keep extending. So the question becomes, why don't you just multiply it out and then just apply the power rule? Well, you can do that sometimes, but sometimes it's easier to go ahead and apply the product rule. Because if we have two different kinds of functions, for example, let's say I have f of x equals 4x squared minus 3x plus 2 times 3x to the 1/2 minus 4x to the 2/3. Now, if it's me and I'm looking for the derivative here, I'm not gonna FOIL this. I just think that would be a little more difficult than just going ahead and applying the product rule. So this is your first function, this is your second function, as denoted by the parentheses. So the product rule tells me, take the derivative of the first, so 8x minus 3 times the second function, so we leave that alone, plus the first times the derivative of the second. And remember, even though these are rational exponents, we can still apply the power rule. So 1/2 times 3 becomes 3/2, and then we subtract 1, and then 2/3 times 4 becomes 8/3, and we subtract 1. So this becomes the derivative of f applying the product rule. Okay, so going back to our notes, we have what is called the quotient rule. So what if we have a rational function in which we have, g over h? This is the rule. Kind of hard to see there, so I'm going to go through it with you. So the quotient rule if we have f of x equals g of x over h of x. So again, we call it the quotient rule because we have a quotient. So you're going to take the top, and in this case, you got to make sure you pay attention to the order. Up here, I mean, I could have flipped the order and done this first. It wouldn't have mattered because we're adding. But here, order does matter because we're going to be subtracting. So when you apply the quotient rule, you take the derivative of the numerator, so that becomes g prime of x, times the bottom, the denominator, minus the top function times the derivative of the bottom, all over the bottom function squared. So derivative of the top times the bottom, minus the top times the derivative of the bottom, all over the denominator squared. And that is the quotient rule. So that being said, if we have 4x squared minus 3x plus 7 over 2x plus 4. Okay, a little simple example here. Applying the quotient rule means that I'm going to take the derivative of the top, so that's 8x minus 3 times the bottom minus the top times the derivative of the bottom, which is just 2, all over the bottom squared. So again, the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. And what's going to happen here is that, you might have up top here, you might have a product up there. Your numerator could be this, in which case when you do the derivative of that, it's going to require you to apply the product rule. But because the order matters with the quotient rule, you're going to have to let that dictate what you're doing. For example, let's say this is my function. Let's say I've got 2x plus 3 times root x minus the cube root of x all over 4x squared minus 7. All right, so we have a quotient, and we're going to let that dictate what we're doing overall. So I'm going to take the derivative of the top, and for me, when I'm doing these sometimes, because there's a lot of steps to them at some point, I might just write it out. So for example, to find the derivative of f, I'm going to go ahead and just rewrite the numerator. And know that I have to differentiate that. And that's times the bottom. Minus the whole top piece, right, which is that, times the derivative of the bottom, which is simple enough to go ahead and do it, so that's 8x, and that's all over, so that's whole thing's in my numerator, and that's all over the denominator squared. So then I have to go back and say, okay, I need to do this derivative, which means I need to apply the product rule. So I'm going to go ahead and apply the product rule to this to find the derivative of this. So that's the derivative of this, which is just 2, times that, plus that, times the derivative of this piece. And again, that's x to the 1/2. So that's 1/2 x to the negative 1/2. And this is x to the 1/3. So that's minus 1/3 x to the negative 2/3. So this right here becomes that. That is the derivative applying the product rule times that, let's not forget, minus the rest of this thing, which is 2x plus 3 root x minus the cube root of x times 8x. So this entire thing right up here is your numerator. So it can get heavily involved in some of these problems that you're working, but whenever you have a quotient, you let the quotient rule dictate what's going on. And you notice we're just applying a bunch of power rules throughout here. So you've got some worksheets. Kind of go through what you're going, like in this, we're just doing power rule stuff. More power rule stuff. Just practicing the power rule. And then determine the slope of the tangent lines. This is a little bit of finding equations of tangent lines, and find the derivative of f, which is what I did here. Plug in the x value to find the slope of the tangent line at that given point. And here we're actually finding tangent line equations, stuff that you've done. It's just like 12.3. And here, more of the same. And then just more straight up power rule stuff. So again, you see the answers are here. Make sure that you're just doing the work on your separate piece of paper and get that done. And then next up will be product rule, and you can see you're going to have to apply the product rule here to find the derivatives. And that's what this packet's all about. And then we have quotient rule. So again, look at your function here. Just sort of ignore all this. That's answer. So ignore it until you get it done. The dy dx stuff means finding the derivative of the function y with respect to x, which is what that is. That's just notation you'll learn next year. Okay, so you're practicing power rule, product rule, quotient rule. And like I said, I apologize I don't have these clean worksheets. I wasn't going to take a trip over to school just to grab them, and I don't have them anywhere. So I figured you guys can work your way around that. So good luck, and I will see you at our next class meeting times. Take care, Highlanders.